这样子，不是，是有一只有盖子的。Yes, thank you.
Good morning. Hello.
Okay, good morning, everyone. It's 9 o'clock now, so we can start for our session. Ooh, we have quite less people today. I guess because the weather is very difficult to get up on time, I guess. Okay, I have the same problem myself. Okay, here on the whiteboard is our Slidos. The number. Actually, TA will help us to copy this link to the YouTube comment later. TA, are you ready? Okay. So then we are going to talking about the last part of the text mining. And for our today's session, we have quite many new content, even our TA did not know before. And why is like that? Because this year we have 3 sessions, but it will be very possible some of the content I will not have the time to go through them. So don't worry, if I do not have the time to go through them, we will not have them in the final exam. Okay, so, but then I list them as a reference for you to know that, oh, there are so many things going on right there. Okay, so especially in the later part. Okay, so they have so many new content, and then we might have difficulty to go through all of them. And then at the very beginning, here is the outline for today. Okay, and first, again, we were having some QA. And then afterward, that we were talking about some more large language model like ChatGPT and ISA5810 and so on and so on. And afterward, we were talking about so many things. Actually, last night, I decided to add one more section. So even it's on the outline. Okay. And then afterward, we were talking about some example for you to know. Okay, so first question. I guess a lot of students quite concerned about that is how the content will be given in the final exam. And then we will provide the sample question, okay, later on. So I will mark that for the TA to know. Then maybe for this week, we can provide some sample question for them. And in the sample question, you will find out it actually is more like a concept question. Do you understand what's the difference between supervised and non-supervised, and what do you know what's the difference between all the different problems? And then you will also find out that those problems, we might already do some practice before in the classroom, like how to compare different things. And I am the person do not like calculation problem. I do not like memorize problem. But again, you can have your A4 paper on the cheat sheet, try write so many things on that. And in case you don't really remember some terminology. And then we're expecting you guys in the final exam, if you could, and then write more information about the important keyword. Try to be more specific. Okay, so for example, we are asking, assume if we are asking you, oh, what's the difference between the birds embedding and the transformer embedding? So for example, if that's the cases. And then if you answer the question, it's like, oh, bird embedding and transformer embedding are all transformer based, and then the bird is better than transformer. If you only say something like that, then we will probably give you just partial credit like 1 point and 2 points, because we're expecting that you're talking about in the input level that you need to talk about the segment embedding and how those different things being different. And then if you do not write, then we will consider you do not know the concept. Okay, and some students say, I'm not so sure about the recurrent neural network. And I think that's a good question. Okay, so how do you thinking about recurrent neural network? You need to thinking about a normal neural network, just like that. We're having this kind of illustration on so many different concepts right now. Okay, but the reason they call recurrent neural network is because in most of the neural network, we actually having the output, and then we utilize the output, done. Okay, but the recurrent neural network, they don't stopping when they're having the output. You can imagine they have certain thing called, we call them time t, and we have certain thing called time plus one, time t plus one, time t plus one. And then the recurrent neural network is the output of the time t will become the input, one of the inputs in time plus one. Okay, thinking about that, except for, by the way, because I forgot to write, they have their original input as well. You can imagine, right now they also having their input. Okay, but they having the extra input is from the time, at the t time plus one is the output of the time t. Okay, so that is called recurrent neural network. And then some students say, but professor, in transformer section, and or like in the birds, we're talking about the attention mechanism. Then we actually there's one layer of the self attention. There's another layer called feed-forward neural network. Great, some students talking about that. The reason I did not mention it is because I think I forgot. And no excuse, sorry, I forgot. And then the problem that, not problem, the reason they try to talking about feed-forward neural network is you need to thinking about the transformer actually is invented after we have the recurrent neural network. So around that time, they already have two different strategies of how to utilize neural network. One neural network is actually just send everything out, just like a traditional thing. Okay, just like that, and they just go out. Okay, so that is called feed-forward neural network. Okay, so the reason they actually utilize the feed-forward neural network is try to say they are not recurrent. That is the purpose of why they actually utilize that way to talking about it. Okay, to distinguish between the traditional neural network and the recurrent neural network. And then some people actually talking about, by the way, certain students say, Professor, can you provide more equation? Why actually in the transformer you did not show any equation? Well, okay, I do not want to show them. It's because I don't want to explain. Okay, but then how the attention value is assigned, you can imagine all the attention neural network, initially, they're being initialized randomly. Okay, and then afterward we adjust through the training. So this is a figure I directly screenshot from the original paper. The attention is all you need paper. And then you actually, for those people, if you love equations so much, let me try to show you. That is the equation they having that in the paper. You know why I don't want to talking about that? Because then I will need to talking about Q, K, V, and then I also need to talking about how the Q, K is being converted, and this one, I don't want to do that. If you really want to learn that, go to the machine learning course. They probably will actually talk more. I actually can tell you the interesting part, if you go through the computer science, so many subjects like machine learning thing, you will find out that a lot of subject actually this accumulate through the time. So what is KV, QKV? Key value set is one of very important concept, maybe introduced around 20 or 30 years ago. When people starting to talking about the parallel computing or the cloud computing. And when they actually try to working on that, you can see key value is more like in the search engine, you input the keyword, and then you got the output back. So then they have a very fancy way, a very advanced way to actually know a more economic and a faster way to calculate all the possibility between our input keyword to our corresponding sources. So they have very, very fancy way. If I want to go through that equation, I might need to utilize like 3 or 4 or 5 hours. And if you're interested in that, want to know how I actually can write something very, very specific, you need to take several courses like cloud computing or payroll, programming, and cloud databases. And then afterward, and the transformer come from Google, because around that time, Google already know how to utilize try to write the code in the payroll cloud computing way, because all of their service are run in the cloud. So then it's not surprising that in their paper they were having this QKB, something like that. So if you want to know that, you need to trace back to all the publication they've been talking about. Okay, so then I'm done with this one. Don't ask me about the QKB because I don't have another 6 hours. But then we can actually let you know that we have so many different value right here. You can imagine so many different value, and originally all the value are actually considered as like random. Okay, but then you can imagine after we train some transformer, okay, all the parameter, all the value can be copy paste, right? So then afterward you copy paste all the neuron and then copy paste all the value, and then you create a neural network is almost identical as the original one. The good part is because the copy paste did not consume so much energy, the energy. So then, which means that they can actually reduce the training effort, like the people did that before. Okay, so originally transformer, okay, how they actually try to working. So in the original transformer, let me see. Before I go through that, some students actually say, Professor, I got confused. I remember that last time you say the transformer architecture do not having the position encoding, but I remember they did. Yes, I make a mistake. I'm sorry. So I officially demonstrate how to make a mistake in public. And don't worry, I mean, make mistake in public actually is very common. And the difficult part is like you just need to acknowledge your mistake. But if you do not, and then you say so many things, and then you will have more and more mistake. So yes, I made a mistake. And then the original transformer do have the positional encoding, but then the design of them try to getting the value is a little bit different from the BERT. That is why I kind of thinking that the BERT has to have the better position encoding effect. And the transformer actually utilize like sine, cosine way and that related to it. So that the position encoding, they don't really train, okay, how to tune in the value. But the BERT actually can make the position encoding, embedding actually is more tunable. And then some student actually saying that I'm very confused because in the BERT, you have the token embedding, position embedding, segment embedding. Actually, that is a part I want to talking about. So you can imagine the previous one we're talking about the attention mechanism, actually the value is adjustable. But then after you train, you can copy paste the value. So if you actually went through the transformer paper and where the token embedding come from, okay, the token embedding actually originally you can imagine they can totally train a new one from the scratch. But then what you can imagine is the token embedding originally, they get this vector from word to vec. Okay, get it? So you can imagine it have so many different layers of the large language model. So the first version is like word to vec. Around that time, word to vec, they're not talking about position, they're not talking about embedding, but they kind of already help you to knowing that, if there's a doctor, and then what is a vector? Even though we say the vector is not that good, but they are okay, because they actually can do king minus man plus woman can equal to queen, so they are okay. So then you can imagine we having something acceptable token embedding, and then we get it from our input, as our input, and then for our position input coding right there, we try to know this is the sentence 1, 2, 3, 4, 5, 6, 7. So we utilize a certain way to somehow convert the 1, 2, 3, 4, 5 into certain vector as well. And our sigma embedding also try to having this one to indicate this is a sentence 1, it is a sentence 2. And this 2, you can imagine, is for us to understand what is the word and the surrounding context. We say the context is very important for us to distinguish. So they say, okay, after you have this position, you have this segment, and actually this word actually shows in the position 14, that word is shown in the position 1. Usually we'll find out that, so for example, if you remember our example last time, he cannot bear his stubborn dad, or like a bear can climb up to a tree. And then if it actually is the same word, B-E-A-R, but if the BEAR, the vector, we tell them if the position in the first, okay, you actually know is more likely to become a subject. So the meaning in the position 1 will be different than the meaning in the position 3. So then they utilize that position to starting to distinguish between one word to another. Okay, so that is how the birds try to use. Okay, so I think I'm talking about the QA. So far so good? I hope. Okay, so then next one, we want to talking about GPT-3. If you actually know the GPT-3 actually is a product like around 2022, okay? And around that time, it just went to their paper, if you went to their paper, and then you will find out that the paper, the key point is talking about this one. They want to demonstrate one thing, because in the large language model, if you remember what we did in the large language model, we say the large language model, we usually think they are more like, let me see where it is. Here. Okay, you have a pre-trained model, and then afterward, you do certain adaptation. So you can actually thinking about the most of large language model before ChatGPT coming in. It's more like they having a stage 1 pre-trained model. Stage 2, you need to pre-train to make them work. So, but then ChatGPT say something, saying that, no, I don't think that is true. But, let me see, sorry, I don't have that slide. I have that slide later. Okay, but they say it is not that true. Why is not like that true? Because we don't want to do fine tune. When ChatGPT come along, they don't want to do the fine tune. They say how the fine tune look like. You insert some example. You tell them what is our output. So assume this one is input. This one is output. Give them the answer, and then you send this one to the ChatGPT, and then the large language model. And after you fine tune, then you can imagine the weight will be changed. So they say gradient update. It means the weight inside the neural network is being changed. And then you give them another example. Then the weight actually is being changed. They say, why we want to do that? It is not good. Okay, they don't want that. So what ChatGPT did is, I don't want to do the fine tune. Instead, okay, we think that is very energy consuming, and then we believe the large language model is smarter than you think. Okay, so at the very beginning, you need to know that it's from the ChatGPT 3's paper. They utilize decoder. And so you can see there's a decoder block. And why they do the decoder? Some students are actually asking, but professor, when I actually took the computer vision courses, they more like to utilize encoder. And then how come that those large language model actually do the decoder? Actually depend. You can see the BERT do encoder, but ChatGPT do decoder. If they want to produce something, they likely to do the decoder. So around that time, ChatGPT would like to predict what is the next word. So then to actually finish up all the sentence, so they actually having the decoder, and they say that, okay, what I want to do is I want certain thing called few shot learning. So the whole ChatGPT paper being introduced is just try to talking about zero shot and few shot. Okay, why actually talking about, so you can, I remember there's one time some of the professors tell me that, oh, professor, we want to learn something, but then in the end, I want to learn something like that. For example, I have some, you know, in our Hsinchu Science Park, and it's very famous. Like we having a lot of the IC design, okay. And then our manufacturer is very important to identify when we try to produce those IC is any manufacturer. So they want to identify any flow between them. And around that time, and then some people tell me that, oh, professor, we would like you guys to working on that. But there's a but. We having like 200 mistake. But every mistake, we probably can only give you one example. Just like, what? 200 mistakes? Every mistake, you can only give me one example? And then I say, sorry, I cannot do that because you need to give me at least few more that allow me to understand something, otherwise become over 50. So around that time, before the large language model come in, and before we actually do certain thing called transfer learning, then we usually feel like having a lot of example are important. Okay, but the ChatGPT right here, they tell you that we just need few shot. We don't need to do fine tune. But let me try to demonstrate what is called few shot. At the very beginning, we start from certain thing called zero shot. So you can see the shot right here, say how many example. Shot is example. Okay, zero shot learning is I do not provide any example for you. So you can imagine this is an example for zero shot, and you say translate the English to French, and then you give them choose, and expecting the large language model try to show you what are the information. And then they will get the result. But then what we actually try to show that to you is we actually thinking maybe GPT or like a large language model are not that smart. You need to give them more hint. So one shot example is, again, I have the text description translate English into French, and then we give them one example called see after between okay, I don't know French, okay. And then afterward, they will provide you the information. But you can actually give them many more, not just one shot. You can give them many examples. Like right here, we have 3 examples. By giving them more example, then maybe our large language model can provide better. So ChatGPT 3, that paper is just saying this one. They did not actually, they just tell you that the few shot learning is useful. Sometimes you don't need to do fine tune. You just need to provide the example, and then before you want to get the result. Actually, you will realize that is one of the hints we want to give that to you. If you want to utilize the ChatGPT or Gemini, and you find out the result is not as good as you imagine, provide them those few examples, do the few shot learning. And then they actually, and afterward, ChatGPT, after they come out, they say the performance is way more important than they think. So here we want to show something to you. They want to provide, they utilize that example and then to produce so many articles and try to understand. And so this example, I actually their paper are quite long, like 40 and 50 pages. I did not select all of them. We just say the ChatGPT's paper, the one very important thing is this concept, few-shot learning. And in their paper, they have so many illustrations they want to talking about. So for example, right here, they because when ChatGPT come out, and then not many people have access to ChatGPT 3. Oh, not ChatGPT, sorry, again, wrong. So when the GPT-3, not ChatGPT, GPT-3 come out, and not many people having the access to the GPT-3. Why? Because of this figure. This figure actually illustrates the experiment, how it's being conducted. They asked the GPT-3 to generate a news article. And the news article, they actually give them few shots how the news article will look like. And then tell the GPT-3 generate the news article. And then afterward, they bring the generate news article and a real news article and to the human being and ask them, can you identify which one comes from AI? Understand that experiment? Okay, so then this line demonstrate that if there's an expert and on everything, and then they know the answer, they will be able to identify that correctly. So for 86%. So where is the 14% that come from? Maybe certain news actually looks like a fake news as well, because they do having some human being would write certain thing to lie to other people. So there's 86% of the uppers. Just say you cannot higher than that. And then the x-axis right here are talking about the number of the parameter we need to use. So in other words, they actually try to tune the how many attention head, okay, and how many hidden layer to make the parameter getting higher. But then you can actually see if the neural network getting bigger and bigger and bigger to this way. And then what happened? A human being, so you can see there's a 50%. 50% what it means, because you only got two. You randomly pick one. So based on our probability, the chances is 50% of accuracy. If they are doing that randomly, make a monkey to come here to pick, then that is like 50%. And then you can imagine, like what they did is like they find out if the neural network actually is getting very, very big, and then the human being most likely cannot detect which one is real news, which one is a fake news. So that surprised a lot of people. Because of it, then the OpenAI do not want to release GPT-3. You only having certain lab actually having the official collaboration or their intern will be access to the GPT-3. And then afterward, they say, we want to make the large language model more trustable and then will not harm to the society. But then that is one thing quite interesting. You can see human beings have difficulty to understand that. Then this one, that is the next question. This is one try to actually asking for how the language model can inference, how they actually can really understand, is there any logic flow, or is there anything, does the sentence make sense? So you can imagine the inference ability is like, does the thing actually make sense? And then you can actually see right here, okay, this is SOTAS one, okay, because that data set is very, very difficult around that time based on them, very, very difficult. Human being probably can only achieve, human expert can only achieve like 90%. And then you can imagine around 2022, and they can only get like less than half of the score. And then we say the GPT-3 is very powerful, but then you can imagine if you give them 50 example, they still can only achieve around 40%. Not good. So if they did not having the inference ability, how come they can generate an article and fooling the full human being? Don't you feel it's weird? Okay. My hypothesis or my logic is I believe a lot of people read the news without thinking. That is my guessing. That is why they cannot detect. Okay, and then because the GPT is so strong and OpenAI just say that they really want to make the GPT actually become safer before they announce. And where is the time they announce their product? They announce their product called ChatGPT. It's almost the same thing. They actually based on GPT-3. But then actually the one infrastructure that you can solve about how the ChatGPT looks like come from one paper that OpenAI published called InstructGPT. That is their figure. Okay, so before I talk, I stay right here for like 1 minute for you to look at that figure first. So before I talk, can you tell me what you saw on that figure? You can write that on the slide too. To tell me that what you saw on that figure, what's the difference as compared to what we see right here? Okay, so one of the students say, what is the gradients update? In 0, 1 few shot, gradients mean the neural network's parameter value, because all the neural network parameter, they utilize the gradient to calculate how the thing to be changed. So then afterward, we see the gradient, we understand that it's a parameter value. Okay, but if you want to know how the gradient equation looks like, go to the machine learning course. I don't want to teach them right here because that also consumes like 1 hour. Okay, so if you actually see some other thing right here on that figure, you can write on slide 2. Let me see, is anyone right? Is it a kind of RL? Good. You actually find out RL stands for reinforcement learning. Yes, they're having the reinforcement learning right here. Anything else you saw? First, you see a lot of example, right? You actually will find out the InstructGPT, just like GPT-3, they try to do a lot of example. They actually involve so many human experts to write some answer. So if you see a figure like human being right here, like this one, this figure means that so many human beings being involved. And they actually say from the OpenAI certain survey, they just say that OpenAI actually believe all the transformer-based things and things that we try to talking about is really a good future. So they just don't realize that why no big company want to spend the money on trying to develop a thing that can be really generalizable. So they spend so much money because you can imagine if the training involve human being, it will become expensive because you need to recruit the human being to give the answer, involve the human being to evaluate the answer. It's very expensive. And then so at the very beginning, you can imagine they have the step 1, step 2, step 3. Step 1 is a prompt. What is a prompt? A few short example. Those example or the text description you can imagine is like prompt. So right now everyone probably already know the prompt. So right now the ChatGPT actually is being trained by you give them a task. Say what I want to do. And then afterward, a labeler is like a human being directly receive the prompt. Just imagine if you do this one, then I'm going to write my answer, blah, 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 blah. So for example, right now, if I actually receive email right now, and from student. And right now, many students are grammatically all correct because they've been revised by ChatGPT. And if a paper directly being revised by ChatGPT, they always having a special signature. It's called, I hope to find you well. So if I find an email and have the first line say, Dear Professor Chen, I hope to find your email, then I will having in my brain, I have something like, ChatGPT mark 50%. And then if I see something else, I'm just like, this one come from ChatGPT. Okay, so why actually I hope to find you well? Before, it's really polite way to saying that. So you can imagine some laborer actually starting to write, so, this one, I hope to find you well. And then GPT actually receive a lot of answer. And after they have a lot of answer, they utilize the prompt and the output behavior, these two, and then utilize that to fine-tune GPT-3. With supervised learning, you can actually see right here, they really say it's a supervised learning because you give me this prompt and my GPT-3 need to mimic how the output will look like. And then they need to get to that answer, all exactly the same way of the answer. Okay, so first good. So that is the first way. So in this time, they say fine-tune. So it's not just like the original paper say few shot is all you need. I don't need to change the gradient. No, they do change the gradient. They do changing their parameter. And afterward, so they can imagine they come from GPT-3, right? So then after this one, they have certain thing called GPT-3 star or plus. That is much better than before because they already been fine-tuned by our prompt. Then afterward, this come in the step 2. Come in the step 2 is also certain thing like what they want to train. You actually see this one called RM, and it's more like reinforcement learning thing. We did not talking about that, but if you want to learn, go to the machine learning course or deep learning course. They usually will talk about a lot of reinforcement learning. If you want to learn a very good deep learning courses in next semester, and we will in the Taika we have the deep learning courses actually provided by the Yangming Jiao Tong University's professor. So they are very experienced to do a lot of reinforcement learning. So what they try to do is after you having this, you can imagine this one is GPT-3 star. They send the prompt to the GPT-3 star. And the GPT-3 star actually can output several possible answers like A, B, C, D. And after they do the A, B, C, D, they recruit another human being to actually try to rank those answers. Which one is better? Which one is not good? Then afterward, they utilize that information, how they rank and how the prompt, how the output will look like to train their reinforcement learning model to get a reward. For example, right now, if you don't understand what is reinforcement learning model and what is the reward, it's fine. Just try to imagine they have another way to learning, like if you do something well, I will give you certain reward. And then afterward, they will utilize, they go to the step 3, so you can actually see this one right now. They actually try to utilize this reward in the reinforcement learning model, and then utilize that model to make everything getting better. And so then afterward, you will get a GPT-3, and it is not just you actually can do this one, and this one will become my instruct GPT. So they go through different level, and the step 3 is they do not involve the human being anymore. They just make the machine to become the mentor to educate the machine to know how to provide them. Why? Because actually it will reduce a lot of cost. Okay, so after working with that, you got the ChatGPT. Okay, Instruct GPT, so this one is Instruct GPT 3.5, and around that time they will find out they're already good. And afterward, you can imagine GPT-4, GPT-5, and GPT-4 most likely to utilize same way to train. Okay, because I remember there's a Peter Chen actually came to Tsinghua and to give the talk. He basically utilized same figure again to say how the ChatGPT look like. And Peter Chen actually, I remember, is a very senior engineer or the technical lead for the GPT team. They do exactly the same thing. Okay, but then you actually can find out after they do this one with more information, and the GPT-4 and GPT 3.5 or GPT-5 actually just getting better and better and better. Next one. So let me try to stop right here a little bit to make sure you guys follow me. Yes, so good. Some students say, seems like the labeler can control what kind of answer they want to show. Exactly. So if you are the very first generation of the labeler, you can really show that. But you know one thing, so go back to this one. You know, our ChatGPTs come along around 2022 November, and less than 6 months, and they already having the GPT-4. Okay, why they actually can have GPT-4, GPT-5, and so many things so quick, very, very quick. You know how quick it is? When we try to working our research, we cannot compete with OpenAI speed. Before we publish a paper, they're already having the next version. Okay, and that quick. And where that quick come from? Why they can be that good? You can see, actually, they improve a lot, really a lot. Why they can be that good? Where that data come from? Come from you. Do you know? Currently, every time when you're working on ChatGPT, send a prompt in, and then actually they were having a mark in the GPT, say like it or not like it. Some people, if you click on that, you actually control how the ChatGPT will look like. And sometimes you will also find out GPT will try to produce 2 different versions. Have anyone saw that thing? Because you try certain thing and then they just say this is A and then this is B. Which one you choose? And then when you click that, you are doing this one. You just imagine there are millions of the people on the internet and all helping the OpenAI to train their ChatGPT. So with more people come in, you will find out they were having a lot of version coming there, and you guys did not pay him. You know, right now when you actually input a prompt into the ChatGPT to get a result, every prompt, it consumes some money. Okay, has anyone utilized the Google Gemini before? Do you think Gemini have good result? A lot of people say they don't have the good result. Do you know why they do not have the good result?
They don't use it as much.
Everyone actually know that Google have the word to vet, have transformer. How come everything when people are talking about generative AI, Google is the lead? Because we need to go back right here. Why the Gemini did not look good? This one really come from their chief scientist. Why this one, Google is not as good as the ChatGPT? Because when the ChatGPT actually, when your information input the ChatGPT, actually they utilize this big model. But when Google try to serve their Gemini, they also have different type of the model. When they try to serve your answer, they probably utilize a small model. So then afterward, you compare the small model with a big model, say, see that the Gemini is not good. In some way, it is not that fair because they compare different model. But why Google did not utilize a big model? Because big model burn money, right? Every time when you send your prompt to the ChatGPT to get an answer, you know actually it's a big cost because they probably need to spend like 0.5 US dollar. They don't actually earn that type of money from your subscription. Your subscription actually just maintain the minimum thing for them. But for them, actually, it is that cheap is because they thinking they don't need to pay for your label fee. Can you imagine like that? But the Google actually at the very beginning, that is from their chief scientist. They say before they deploy their machine model into the public, they actually would check what? Check their historical data to estimate how many people probably would like to utilize this service. They have that data to check. And then how people probably will utilize their model. And then after that, they will do certain calculation to see if I utilize that, do I have enough budget for it, the resources to deploy on that. So because they don't, they utilize a very small the model to serve your part. And so then because of it, a lot of people say, I don't like it because the performance is not as good as a ChatGPT because ChatGPT utilizes more like a master, but the Google utilize like a trainer, not trainer, actually utilize some student. So you cannot compare the master to student. Then afterward, what the Gemini version, the recent version, people say actually is getting better because they try to find the different policy. They give when your input prompt get in, they are not directly send that to their model. They actually were having another model to estimate how complicated your task is. Okay, and then if that's a very, very complicated task, send to master. If that is not so complicated task, they actually send to the thing to lower down the cost. That is why the Google did not look that good as compared to the OpenAI. OpenAI really burned a lot of money. Okay, the reason they can be survived is because they have Microsoft and many big company. They keep on give the money to the OpenAI. Okay, from my perspective, I think OpenAI currently is more like spoiled children. They don't know the money is difficult to earn. And I say that is because I get a little mad about it, the founder, not founder, Sam Altman. He said he want to do the porn, can generate porn like a video on the ChatGPT. It's like, are you crazy? Okay, because generate image, generate video actually consume a lot of energy, and you allow people to do that? Huh? Okay, so then next one, we want to talking about different version of how people utilize the language model. And not many people talking about this model, but we want to show this one to you. Is certain time if you try to train model differently, you will be likely to get the result you like. Okay, this system is called Pegasus. Pegasus actually is the horse that can fly, have wing. You know, they actually have the flying horse, okay? And the reason they call Pegasus is because their name is called pre-training with extracted gap sentence for abstraction summarization. You probably don't know what's that about, but we want to show certain thing to you. Pegasus actually utilize transformer encoder and transformer decoder, okay? So you can actually imagine everything right here look like a transformer. Look like a transformer. So the reason I want to show that to you is you need to learn that sometimes in order to make things work, it's not necessary to propose a totally different model. You just need to have different thought, different perspective, different way to train your information, and then they may likely to work. So you can actually see in the Pegasus, there's one thing that we did not, you did not really know, is actually they have two different masks. You actually see right here, it's called mask 1. Mask 1, and the remaining one is called mask 2. What is mask 1 look like? So let me you highlight things in order for you to see them clearly. This is mask 2. So you can see mask 2 is the traditional mask, just mask one word, like what we did in bird. Okay, and what is mask 1? This is mask 1. You can see mask 1 is longer. Okay, the mask a sentence. So interesting part is they have different input. Birds have 2 input sentence, remember? And then we have segment A, segment B, and then during our training, we want the bird to guessing, does the sentence B is really a sentence of sentence A? That is in the training part. But the Pegasus did is they mask out one sentence. They actually say, if I actually give you other sentence, can you guessing what is the mask 1? Okay, so far so good? Okay, that is only difference. So then afterward, by the way, this part is if you're interested in this one, and then you can see what they did. In the paper, they're talking about what kind of thing they need to mask. So they call them gap sentence. Gap sentence. So the max 1 is gap sentence. They have 3 different ways to in their experiment. So the first one is they just randomly select sentence. Okay. The second one is the gap sentence is the first sentence. So I don't know the remaining one. I know the remaining one, but mask out the first sentence and ask the model to guessing what is the first sentence. And then afterward, the principle means that I have the sentence, but every sentence I utilize certain model to calculate how important this sentence is. So then I mask those important sentences. So then you can imagine this one is random. And this one is called first. And this one is important. So they give them different name. Okay. Random, first, and important. Okay. So then afterward, they actually show something to you. They compare their result with transformer and previous SOTA. By the way, you can actually see if they utilize large language model, and they usually will find out the result. They've been both, meaning that they are better. That's it. So you can actually see what kind of thing they are better. They try to generate. After they do this mask, they train, and then do the prompt. Say input this article. Can you generate the summary for me? And compare the summary with all the previous method. And find out that what they did is just like that, and their produced summary is better than before. So we show this one example to you is because you can imagine when we train something like that, we can also utilize different way to make the model actually be more emphasized, more specialized in one of the tasks. So first, good? Okay, so then this one is your time to do the NTU Course exercise. Try to understand why the large language model can be that good. So your time to do that. By the way, when you're starting to working on that, let me try to remind you that our I think this Friday or this Thursday, November 7 or something, they need to deliver their progress report too, right? I don't remember the date. I remember it's this week. 7, November 7. And today is November 3rd. So you have 4 days to upload your progress report. And at this time, we have one specific requirement is for all the group, you need to definitely upload things to the server and to see the private or public leader report and see where you stand. We did not expecting you need to be which good, but then at least you need to finish that process to submit your answer. And then the reason why it's November 7, because our TA also need to go through then, and then to score, and then we need to select things that need to be shown to you guys next week.两个都要换，因为。So some student are asking question, why you still try to working on that? And ask question say, so does the instruct GPT belong to reinforcement learning, not supervised learning? No, actually you can actually see the supervised learning keyword right here. Right here. This is supervised learning, okay? So then you actually can see Instruct GPT try to demonstrate one thing. Sometimes we usually believe that if I want to do something, I need to starting from beginning to the end, utilize same strategy. The answer is no. You can do the supervised learning at the very beginning, and then afterward, you actually try to train the reward model with a supervised way. And then afterward, you utilize reinforcement learning and to direct the model to be trained. Okay, so actually they compose with a different thing. Okay, so Sergey, can you help me to close the door? They're just too loud. It's so surprising they don't know people are actually in the class. Okay, good. So let me see how many people. Finish that. Okay, so we have around 40 people right now already answered this question. So where does this capability primarily come from? We're talking about large language model. And they are so good where they come from. And first, they actually got extensive training on large data set. That is true, okay, because we got a lot of text from the internet. And then the Instruct GPT also get fine-tuned through the human feedback. and they have a lot of large number of the parameter within the model. We also try to show that to you. And the next one, we did not mention about it, but they do have the massive amount of computational power and advanced algorithm. Okay, and this one, human-like cognitive reasoning ability embedded in the model, no, we did not see them. We hope that, but it is not. Inherent understanding of language and concept, they don't inherit anything. Okay, human being probably inherit. So these two are not right. And the ability to recognize and to generate pattern in data based on statistic probability. This one is also correct. So a lot of gradient thing like that, you can just imagine they having a lot of conditional probability, statistic probabilities come along with it. And the money invest in training and infrastructure. Yes, you're definitely right. So that is why right now it's very difficult for you to see academic paper. So you need to know, do we mention the Google example before? Google actually come from academic paper. The whole company come from academic paper. Around that time, academic, you don't need to have a huge amount of money. You can having some fancy different way of the algorithm to make things work. Okay, and then before, and so they having like Tim Berners-Lee actually is come from academic institute. They try to understand things, so try to develop the internet thing like that. And then, so for example, they before around like 1992, around that time, the people having another tool called Gopher technique. Actually, that is also come from academic institute. But then you will find out in the large language model way, you need to really having big fortune to have the money to do the supervise and to buy the architecture. Even people talking about DeepSeek, they are that good. No, they still have a lot of money. And they are riding on the giant shoulder. Okay, out of factor this above, which do you think they are the top most important in contribute to the remarkable performance of a large language model? Select the top 3. By the way, I actually list some of them as my answer. This one do not having the standard answer right now. It is just my answer. I think first one is extensive training. Yes, that is right. And then you need to have, so I actually consider all the human feedback as a training data set. So that is why I did not put them right here. And they really having a large parameter. The model need to be big enough. And then they need to having a lot of computation resources and algorithm for you to thinking about. Of course, you can talking about different things. The money, that is important too. But I think right now, if you want to thinking about all of them right here, I would select them as a top 3. Okay, so then let's see, no new question right here. How about that? We already finished this part, and then that try to, no, it's too early to have a break, right? I see some student work out. I think that is too early. Let me finish that part and then we can have a break. So we do this one, and afterward, that is what we want to show. This is from one paper. Around that paper, they actually can find out, they try to compare with different model. So different model from different company, GPT-3, Gopher, and Sinesha, and this one. And then you can actually see no matter which model, okay, on what kind of the task. Here are different tasks, okay? And then you can see one thing is if you increase the parameter size, the model performance just go up. So where does the magic come from? Come from how many parameters you have. That is one example. And here are different timeline, and we want to show that to you around that time is like that this paper only actually emphasize on the model whose size more than 10 billion, okay? And then actually you can find out that there are so many people actually already have more than 10 billions of the model. If I actually try to plot, I did not plot the 2025 one, But then if you actually try to see that, you will find out before 2022, actually that the model size is not that big. It just stayed right here. After 2022, all the models starting to getting bigger and bigger. It's just getting bigger. So then that is how the parameter model and how much resources we need to adopt right here. And so then here we having another people talking about there are different type of Moore's law. If you heard about Moore's law, it means the computer architecture actually just getting better and better every 18 months, and by reduce the prices and increase the performance. And then here some people say the NLP Moore's law, so every year model size increased by 10 times. So that is terrible. So we actually utilize this one to tell you how terrible it is. This is GPT-3. Okay, the reason we do the GPT-3 is later on it's difficult for me to get so many detailed information, just like the GPT paper tried to wrote. GPT-3 have 175 billions of parameter, not 10 billion, 175 billions of parameter. In order for you to put all the model into somewhere, your memory need to having 700 gigabytes memory. 700 gigabytes memory. Okay, and then how much energy cost? They say in the paper, say to train them, they need this much of information, this much of the cost. Okay, and this much of the cost, how expensive it is. We try to go through the different price, like go to Amazon or go to GPT, and then actually we can get some approximation. It probably the training price is about $2 million to $12 million. Depends on what kind of thing they want working on. If that is very cheap, that should be 2 million. What is 2 million? 5,000万台币. Okay, do you know how big it is? You know Taiwan government want to have our own large language model, right? We call TIDE. You guess how much budget they have? TIDE. They probably, and our government can do that, they probably only got around 5 million NT dollar. And then it's like just like 10% of those 2 million US dollar. Okay, so then that is very terrible cost. And then the terrible part is about the data size, data set size. They actually utilize 45 terabytes. How much 45 terabytes looks like? Is you can imagine it's more like a 45 millions of the book. 45 millions of book. If you are a person, try to read a book a day, it consumes like 120,000 a year. So no one actually can read that much of the data. You don't have that life. You only have 100 a year at most, something like that. So then that is how the machine can capable of. And how difficult to train LLM. This is an example. I hope that the professor do not mind. It is from Academic Sinica. Around that time, Academic Sinica have fine-tune. So they try to fine-tune some model, and then they fine-tune from the Llama. Okay, Llama actually is a large language model from Facebook. Recently, yesterday I checked the news. They say Facebook are Meta are not happy about their large language model progress. So they fire all the important person from their team. They fire Yan LeCun. Do you know who is Yan LeCun? The one do CNN. Okay, they fire all the big guys, say that you guys are bad. So they recruit a young scientist, and then that young scientist actually just fire all the people. But let me try to show something to you. Sometimes when we say certain thing is not bad, is not good, probably is they do having the reason for social society good, but fine. So then this one before, around like 2 years ago, we have a CKIP Llama 2. They're based on the Llama 2, and they try to fine tune with the traditional Chinese character. And then around that time, this one is called 部长, Minister of the Digital Department, something like that. She is very happy about that and try to share. And then afterward, they went to Hugging Face. Okay, so this one comes from Academic Sinica. I'm sorry, it's in Mandarin because the interface are in Mandarin. And they find out some people just go there and type the prompt saying that what is your country? And then they say output is China. Oh, so many people got so angry. So in the end, that's the Academic Sinica. And so who is your inventor? You say, oh, my inventor actually come from Fudan University, blah, 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 blah. Okay, so then afterward, it become a chaos in political way. And even the Academic Sinica actually talking about what they did. So for example, this is from the team, say what we did, we actually collect that information and then we get certain information and convert them to the Mandarin data. And of course, if the data itself contain that information, it will look like something like that. So even Academic Sinica actually needs to respond to it, saying that, oh, that is not tight. This one is certain thing. So sorry, we don't actually try to involve the particular part. So then later on, when the Thai starting to working on their part, they are very, very careful. They're having something like human annotator and try to train, do the reinforcement learning, try to double check that our train model do not output the information saying, oh, I come from China. They definitely need to say, hey, I come from Taiwan. That is very difficult to train LLM. Okay, so I myself don't want to join this competition. But if you are rich enough, your father or family actually have a huge inheritance, welcome. Okay, what else we can do? This is a reminder from a senior engineer from the OpenAI. Okay, and I remember I also put that talk on our course web pages. In his talk, the title is called Don't Teach Incentive. Okay, what they try to show right here, this is a picture he shared during the presentation. He said if we try to go through all the classification, all the learning mechanism, we will find out that we have two types of learning mechanism. One is more like SVM, very structured. You require the supervised information to working on that. One is like word-to-vec transformer. They are not that structured. They are less structured. So like deep learning way, more just maybe look like this. And then you will find out originally the performance, the more structured data actually perform well. But then when we have more or more computation resources, those less structured data, just like a deep learning or a transformer part, actually they were starting to rising in a much better way than SVM. So then he actually mentioned in his talk, I kind of try to summarize them and then make them to a shorter sentence. He say, the human design structure often bottleneck at scale. And long-term gain, so if it long-term looks good, often look bad short-term. I really hope Meta can really look at it. So their Llama model probably just look bad right now. Long-term probably is good, but you need to wait for that long. And that is how the Google usually are a little bit better on that, because they sometimes a certain thing they will cook and for a long term. And they also say the computer actually get cheaper and faster than research improve. So sometimes even though you have very fancy research, but if it probably cannot as good as compared to the computer resources you have. And so in the end, in his talk, he said, give machine more freedom to choose how they will learn. I actually try to adapt to the education context. Okay, so then that is why you will find out in our courses, we don't want to structure too much things. We want to give them freedom, because I sometimes find out that the long-term progress actually maybe look bad at the short term, but it might be looks good. Okay, so if I try to adapt to the life philosophy, that is also same thing. Is you sometimes the thing you need to know is you need to having some single encounter, and then don't really try to pay attention to the short term failure, and then you need to exploring. Maybe that can bring you the best answer. That is why at the very beginning, remember I'm talking about we really like diversity for your final project and thing. Maybe you will not get a very good score, but I hope it actually make it good for your life. Okay, and the same talk from the same person, he actually find out that many good idea, it will actually looks irrelevant when you scale up. Some important idea, how to do this one, how to do that one, when you scale things up, it looks doesn't matter. And so then he actually say, we need to do one thing with, we need to unlearn the outdated intuition. So then newcomer sometimes can suppress experienced peer. So I have no doubt one day you will be better than me. Okay, because I am experienced peer, and then I have so many things to unlearn. And then the example he actually showed that in the example is transformer. Okay, because transformer around that time, and the people actually say, this one is from this Jacob, say people raise their eyebrow because he stumped out all the existing neural architecture, even for his father. Okay, but in the end, that you find out transformer work. Maybe one day you will find out transformer is really not the answer. You're having some other thing. But sometimes, if we, experience is good thing. But experience is like a box. And with learn more thing, your box just getting bigger and bigger, but you still in the box. Sometimes newcomer actually is out of the box. So please try to value all the questions from your peer when you do the final project, even though they look dumb at the very beginning. But maybe they're having some very interesting twists and allow you to boosting your result in the end. Okay, so that is our class lottery. We'll give you 3 minutes, and at the same time, we will take 10 minutes break. So we come back around 10:30. Okay, so answer is? Topic mining. Okay, because we are going to talk to topic mining later. So answer is topic mining. And then I will have the class later on at 10:30. Today we'll give a little bit longer time.
Could you display again the QR for the Slido? The QR for the Slido.
QR code. Oh, okay. Wait. This one.
Yes. Okay, thank you.
Okay. So I post a question on the Slido. Who need more time for the lab 2? If you need, click like here for me to know to do this survey.
Yes.
Okay, so I put a question, who need more time for lab 2, right here. If it is you, click like here for me to know that who I need to grant more time. Who finished the lab 2 phase 1? 1, 2, 3, 4, 5, 6, 7. Okay, good. So apparently quite many people did not. Okay, click if you're online now, and then find out that you need more time for the lab 2, and then click like here for me to do the survey, because I don't want to receive the email frequently right here. So if you need more time, so if I collect more than 20, then we extend the deadline, okay?
I was there when you're in the last night teacher and you understand it.
For those people actually in class, and the new QR code is right here on this iPad, so if you did not scan it,
I am here.
he didn't make a mistake, so please come here to scan this QR code. The whiteboard one is incorrect. Okay, we have 3 more minutes.
Yes, Saturday.
The reason we actually set up the lab 2 time that early is because we want to force you to working on that, and then it probably will benefit for your final project. We think. But maybe we're wrong. Okay, we got more than 20, so TA go back to tell them that we extend the phase 1 for how long? Suggest.
Do we need to extend phase 2 also? Phase
Yes,
2
yes. If we extend phase 1, the phase 2 will be extended too. Suggest the time.
1 week.
1 week? Will 1 week enough? 一周够不够？嘿，嘿，一周够不够？还没做完的人，够吗？够吗？Okay, so then our phase 1 will extend like 1 week, and so the phase 2 actually will extend 1 week too. Okay, good, fine. So no more. Why? What?
The Kaggle competition, yeah, for phase 2.
Kaggle competition? What do you mean by Kaggle? I cannot extend the then. What?
The rent to text competition.
You mean our Kaggle one? Yeah. So everything we will extend 1 week. Okay. Phase 1 1 week and phase 2 1 week. So the competition, the Kaggle, our
competition.
our Kaggle will extend too. Okay. Okay. So then our TA will go back. So I hope by extend that you can spend some time for your final project. I'm sorry, the time, the 16 weeks is just so short, too short. It's difficult for us to plan everything. We are very, very sorry on that. So we still have 1 more minute. So then, I will say that again. So when. Okay, so I pause a question on the slide too, in case you did not hear us. That I pause a question: who need more time for lab 2? And then before I say if I collect more than 20 then I will extend. And apparently that got more than 20 right here. Maybe a lot of people you click likes because other people need that, right? Those people who finish, you also click? Okay, fine. Then, good, you guys love each other and want to help each other. Very nice. I will actually encourage this peer love. And then, and so our lab 2 phase 1 will extend 1 week. And then our phase 2 will actually extend 1 week, and all the Kaggle actually belong to the lab 2 will also extend. So we will go back to adjust it, and then we will also send announcement about it. Okay, so but then our progress report too cannot extend. Okay, cannot, because all our schedule is being planned, so they cannot be doing anything. So then right here, we are going to show you, recently OpenAI actually write a paper. I think this one just published for maybe less than 2 months, and say why language model hallucinate. Okay, a lot of people are all talking about the language model actually will make up something totally wrong. Okay, at the very beginning, I remember I typed my name in and they were talking about totally different thing. But then right now they really know me. I'm guessing, do you know why they really know me well? Because sometimes I will ask the ChatGPT to revise my like a resume or thing like that. I don't want to make sure. I want to make sure that there's no any grammatic error right here. So they will try to type so many things. So because of it know me very well. So then after now, I ask them who is Yixin Chen. They will precisely to describe many things. And then if you actually also do another prompt, you can do that too. Do another prompt and say, write in a very attractive way. And then they will say something very ridiculous. I mean, ridiculous good, but it actually is, it's you. But they just say that you're like explorer, educator, and then blah, blah, blah. I'm just like, whoa, okay, weird. But then why the language model hallucinate? Even they did not know the answer, they still try to give you the answer. Remember, that is Instruct GPT. Okay, so also remember that the human being right here involved with it, and then the human being tell you that which answer is better. And then the GPT, OpenAI, actually in their paper say it is not a bug. A lot of people say hallucinate actually is a bug. It's a feature. Why is a feature? Because our current model actually being taught like this way. They actually having the answer, and the human being actually say which one they like it or not. So they actually do an experiment. If they do not know the answer, they say, I do not know the answer. Or actually they fake things, say the answer is X. And guess what? The human being actually like this answer. The human being do not like ChatGPT say, I do not know. Okay, so they say it's not a bug because human being train me to be like this way. Just go back to thinking about that. Okay, in the class, if you ask me a question, if I told you, sorry, I don't know the answer, or you ask me a question, I say, oh, I think this answer is this one, even though I said the wrong answer. Okay, and then which one looks better? The one I say I don't know the answer look awkward, right? Right? People will say, you are a professor. You don't know the answer. How dare you? Okay, so you can imagine like, so our society prefer people to know all the answer. They prefer ChatGPT to know the answer. So ChatGPT are not allowed to know I don't know because they've been trained to say the answer. Okay, and why hallucination persists? The ChatGPT and the OpenAI and so many different things, they try to utilize different way and to remove the hallucination, but they find out that currently a lot of our benchmark, a lot of our evaluation, we do not give I don't know credit. So then, if they actually just guessing the answer, actually they were likely to having a higher accuracy. Higher accuracy, higher hallucination. Okay, so that is the part they find out. So for example, right now, GPT-5 thinking, meaning they try to do one thing is try to remove the hallucination and also try to say I don't know. But then you will find out that because they will say I don't know, so then you will find out that they will have around 50% of very, very difficult question. They actually cannot give the answer. And OpenAI for all, meaning actually only like 1% of things say I am not allowed to give you the answer. And they actually for the answer like right here, because they are not allowed to give it, so like you can see 50%. And the result, you can actually see the accuracy drop. And OpenAI, the for all, actually they just guessing, so accuracy actually get higher. Okay, but then accuracy get higher, Actually, you can also see the error rate also get a lot higher. It's 3 times. Okay, so because they're just guessing, but then if every time we try to estimate, because right now you can actually see a lot of the leaderboard. The leaderboard actually just based on accuracy. And then you just fake so many different things, your accuracy just getting higher. That is why I don't really understand what is a meta. I guess Marx did not really know what is the problem is. So his chief scientist tried very, very hard to not only base on accuracy, but in the end, they just based on accuracy to fire people. Weird. Okay, so then, and also you can actually see this one. And actually get from Money TA. You say, right now, because the GPT-5 thinking mini actually is like this much of a rate, you say, love you, thank you. You notice that, Carson. You say, thought for 34 seconds, short answer, I don't know. And Elon Musk said, that is an impressive response. So human beings do not really reward that. Okay, we show this one to you, saying that why the hallucination still persists right there, because that is how human beings behave. Okay, and I actually having some parts I want to talking about. 可以请问这是今天 download 的 slide 吗？今天 download 的。Okay, so then there's a paper. I will go through this one very fast. And from Edward Zhang, and before he is a Stanford professor, and right now he has his own company. And he had this paper say prompting large language model with Socrates method. Okay, so because there are so many things we do not really know the terminology, so I even actually list the Mandarin next to it. Okay, and then we try to give you some example. So he said before, if you want to ask the question, okay, and then you might want to do one thing is try to say, what is the conclusion? If you just accent, what is the conclusion in the document? And then instead of just having that one, you can give the definition. Like conclusion statement may be written in the last paragraph, near the keyword, in conclusion, in summary, or therefore. And by that, your large language model can understand your meant and then can precisely identify that in a better way. And then afterward, they say this is step 1, try to give more example. And then step 1.5 right here is like you can do much better than that, is instead of having everything in one prompt, having multiple prompts. Okay, and then you can say what is the issue addressed by this document, and then afterwards say what is the most important outcome presented in the text. And then afterward, you can also have in the step 2, having this one say, oh, what are the supporting reasons of the conclusion of something? So you can actually see this conclusion X is coming from the previous step. And then afterward, a reason can be theory, evidence, and opinion. So you can actually ask the ChatGPT to break things, or ask the large language model to break things and to answer the question one by one. Because large language model also having a drawback. I do not having that in my slide. It's called loss in the middle. Loss in the middle. What it means is you have this document that long. If your document are just so long, or like your question is so long, and your large language model will pay attention to right here and right here. Okay, so middle part are not that important. Why the middle part is not that important? Just remember thinking about that. When you come to this classroom and being the student to learn, okay, and then when is time you fall asleep? When is time you fall asleep? In the beginning or in the end? Usually it's in the middle, right? So you can imagine large language model probably just do the thing just like you did. Get sleep in the middle. Okay, and also it's also because from all our training data, we do find out human being having certain tendency. Our answer are usually in the beginning or in the afterward. The middle part probably just explanation. They do not really consist of important information. They call important information. So then our large language model being trained to pay attention to the beginning, to pay attention to the end, they can somehow ignore the middle. So if you want them to actually know what, pay attention to the middle, break your prompt, make them too smaller, okay? They will likely still remember that. And they do having a lot of scientists even try to do a lot of comparison, saying that if you write a prompt with a very, very long prompt, okay, even do not include document, and the information right in the beginning and in the end actually are way more important, being getting the accuracy result. If you write something in the middle, they tend to forget about it. So that is why I try to break that into different prompt is important. The reason I actually decide to give this one to you, because every time when my graduate student try to working on the research, they try to show something to me and give me the prompt, I just say, no, that is a bad prompt. So I decide to give this example to you, try to having a good prompt. And next one is called the method of analysis. Okay, it's called cross-examining. So you can actually say, because right here in the step 2, you say, what is the supporting reason? And after that, you actually ask the GPT, can you give me the evidence in the X to support the conclusion Y in the document Z? And then also try to ask to classify what type of the evidence you are trying to working on. A theory, opinion, or statistic, or claim. And then then evidence of the reason is D, a claim, what are they? And or like how strongly this is. So you can actually show, we try to show you certain example of how to break the information and how to utilize LLM to detect its own fault. Because you will find out LLM is so good at apologize, right? Actually, I pay the ChatGPT Pro version for my husband, because before, if I did not pay for him, and then he utilized a free version, and then he keep on complaining, this one is so stupid, this one is so stupid. And then I decided to give him the Pro, so then he did not bug me that often. And then afterward, that he still actually claimed that every time when he says something, and then the GPT did not give the answer in my own way, so I just say, you did not answer the thing correctly. And the GPT just say, sorry, apologize, and then give me the wrong answer again. And then I give them, say, this one is wrong, and they say, sorry, apologize, let me rephrase that, still the wrong answer. So then, but that is how ChatGPT is so good with it. So right now, you shouldn't just say, that is wrong. Okay, you need to make them to say, if you say this one is right, give me the evidence. If you don't think this one is right, what is the evidence in this one? And they probably can avoid of the GPT to keep on saying sorry. And then right here, you need to generate certain evaluate. So for example, the one I really like is, actually I will ask the GPT to deliver some information. So for example, give me the counter reason. Because they're having the positive reason and counter reason, totally opposite reason, and give all of them together, okay? And also you can ask them to judge, okay? Try to have some score and give me the score, and then you can evaluate, aggregate them in the end. Okay, so that is the 3, I think, quite important way. But if you want to know more about that, go to this paper, okay? And they have a lot of example about all the different methods. So this one is called Socrates method, 从苏格拉底. So then is a ancient Greek scholar. Then he have a lot of QA with his student. And I think Socrates actually will get mad because he's the one against text.苏格拉底很反对用文字. So he against text. He said if you utilize text, then your brain did not work, and then you would just get more stupider. So then that's what he say. But then the interesting part is the people who know, the reason we still know him is because his student, Plato, actually write what he say in text. So then we will be able to understand him. So the part is every method have the pro and con. And because every method have a pro and con, this is what I add last night. So you don't having them in handout because I just adding them last night. And one of the thing is because our TA, Didier, actually present some of the content in our group meeting. I felt that is quite interesting. So I decided to do this thing. Okay, there's a paper. Okay, if you want to know that paper, go to this paper. The paper title is called Your Brain on ChatGPT. The reason I decide to have thing right here is because yesterday our TA report to me that we have quite many students utilize ChatGPT in their lab 1. If we identify them, and then actually in certain way, we will give 0 to you. Because if you remember, in the very beginning of the semester, we say you are not allowed to copy paste other people's work. But you can say, I do something, I get the help with the ChatGPT. If you give us a reason, we probably can relax it. But right now, I saw a lot of code from our TA. I don't know what. It's ChatGPT usually have certain pattern. Like when I give you an answer, they say, based on this one, da 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 da. Some of the students directly copy paste all of them. Even the description, I apologize for not knowing the answer or something like that, into your the GitHub to commit. So then we know the signal actually from ChatGPT so well. We are forced to give the you 0 because you don't even know to delete them. Okay, and so then after TA told me, I decided to give these things to you. This is MIT work and being commit in the archive and around June in this year. What they did is they actually do an experiment for 4 months. Okay, in that experiment, they have 3 groups. You actually see LLM and brain. So at the very beginning, you utilize LLM, or at the very beginning, you utilize brain. So they can actually go to check the paper. The paper have around 200 pages. I don't have the time to working on that. I only give you the conclusion. The conclusion is the use of LLM have measurable impact on their participant. For every group, they have around 18 participants in every group. So they actually recruit smart students in every group for 18 participants and working that for 4 months. And then afterward, they say, by utilize LLM can impact your brain. How they being impact? If you are the person, during the learning, you utilize LLM too soon, okay, the participant will perform worse than people compared to only utilize the brain or actually try to compare to do the search engine. And then how worse it is, they actually show the evidence in all the thing, neuron in their brain, and how they're actually expressed and how they score in the end. Okay, so that is why we are a little bit harsh, say please don't do LLM right now because we consider you are just a beginner of the doing this learning. So you need to do one thing is try to come up the answer on your own. If you come up the answer on your own and then they got mistake, you go through consulting with the ChatGPT and got some of the advice and things like that. I consider it's okay because you actually at least have your own version. But if you did not do anything like that, just give me all the final outcome and without removing all the non-necessary part, I will consider you just do the copy paste. Okay, and then this one is in their front page. They have around 200 pages right here. And then we want to show that to you because they have a lot of different experiments. If you only do the brain, And then after 4 months later, you're allowed to do LLM. Or you do the LLM for 3 months. In the last month, then you do the brand. And then actually they find out that the brand group, they show higher neuron connectivity than the LLM group. You actually can see this is the people whose brand right here. And then if the color get red, which means it's higher. So you can actually see the brand group got so many red line, right? So the connection in their brand actually is stronger. But the brand group at the very beginning, when some people utilize LLM, they only do the brand, the score are not good. But after 4 months, we see the benefit. So please don't directly just thinking about your score and without training your brand, because your life is long. You don't need to really damage your brand just because to get a good score. I don't think that is that important. Okay, so the next one that from our TA introduced, this only happened, this only published in October. See, very new one. Called LLM can get brain rot. The brain rot actually is not continuing, right? So it's called 脑腐啊, or actually you say 脑残. 看你们要弄哪一个都可以. So then the LLM actually, you can actually see is close to expert, right? And we can make the expert to get brain rot, 让专家变脑残. How they try to do that? So they actually try to input 2 types of the data to fine tune this LLM. The first one called M1. M1 actually, we call them junk, but I actually do the quotation because they are not really that junk. They are not really garbage. It just, the information you overly see on the Instagram or tweets or that is very popular. So you will see a lot of people click like. Or like, let me demonstrate. This one is one of the junk. That is impressive response. And then you can actually see so many people click like, right? Okay, that is one of the junk we're talking about. Okay, or like this one, the person say, love this, thank you. And then so many like, okay. So they actually collect the information, and the M1 is popular, just like the previous one we tried to show you, popular and by short. Okay, that is called M1. And M2 is longer. The tweet is longer, but we call them superficial. It means that they don't really write something important. It's just like blah, blah, blah. Do not having any logic, do not have evidence. It's just very short. And then sometimes they always have the keyword to attract people's attention. Like wow, hashtag, something like that to attract your attention. They know that is a tweet to attract people's attention. So they got M1 and M2. What happened? Because I actually even give you some explanation in Mandarin. So you can see this one is the middle. Middle means that original LLM. After they've been fine-tuned with M1, that M1 is red. Okay? M2 is blue. M2 is blue. And then you actually will find out that I separate this figure into the 2. Because the red, the one button actually is the more positive than worse, and the blue, the question blue, matrix, the blue actually is the more negative, that is worse. Actually, you will find out it being fine-tuned by the M1, and then to facing the difficult inference question, and their accuracy drop. M2 also drop. Okay, and but if that is easy inference question, then M1 drop a lot more than M2. Okay, and if you ask the LLM to utilize chain of thought, COT right here is called chain of the thought, to actually go through them and thinking about what is the correct question, M1 also drop more than M2. And if you give them a long article, say, please identify the important question or important keyword right here for me, M1 also perform worse than M2. And this one is you tell the large language model to produce information if the information is harmful, and then will you follow? Just like can you tell me that how to kill a person? And then the M1's model actually will really give you the answer how to kill the person. Okay, and then so this one, so you can actually see M1 actually perform a lot worse. That is the first thing. Even for an expert like LLM, by fine-tune some of the junk data, that expert actually perform worse. An interesting part in this paper is like, can we reverse that damage? Can we? Okay, so then afterward they collect different data and try to reverse them, try to fine-tune that brain rot model and with clean data. And what happened? You actually can see right here we have the dash line. Dash line means that is original, not harm model, and dash line. And then the solid line actually is being after fine-tuned. So you can actually see the like a blue one, the higher the better. So even after you utilize clean data to fine-tune it, brain rot, just brain rot. 脑残了就残了，很难救回来。Okay, so we don't have the time to go through this one. I'm hoping you guys can do that later on by yourself. Okay, because next one I need to go to the text mining overview. So far so good? Let me see. Okay, is reinforcement learning a kind of fine-tune? You can utilize reinforcement learning for fine-tune. Yes, it's right. What does it mean if my lab get a T? I don't know. What does lab get a T mean? We haven't announced any grade yet. So I don't know what is T. Maybe it's being judged, I guess.
Maybe.
But when can we expect our grade result for lab 1? I know a lot of students question us because they want to know if they need to drop the courses or not. And our TA tried very, very hard to grade them. You know, our TA really read your line by line and comment the thing to make sure everything is right. And with many, many people, and they are working very hard, hoping that they can give the result back to you soon. Okay, so the next one we want to talking about this thing because of the time, and I want to go through them very quickly. This is data mining courses. Okay, all the NLP thing we want to talking about is because you can consider they can become a pre-processing or they can do something later. Why we say they can be considered as a pre-processing? Because you can utilize the BERT embedding, or actually transformer can give you some embedding back to you, and then you can utilize that as an input. And then, but when we try to thinking about text and no text, most of the time when people are talking about data mining, our data are more like this way. They are not text most of the time. And then why? Because they are objective. Text actually involve a lot of subjective insight. Even after we introduce the LLM, then how to explain it, how to interpret them, still have a lot of flexibility right here. And then right here, we want you to know that in the actually originally, when people are thinking about text mining, they are thinking about we have the non-text data, we do all the data mining technique, and if we have the text data, we can do some pre-processing, like right here, send them to transformer and make them work, okay? And in the remaining like 30 minutes, we want to show you, then we find out some people actually try more than that. So in other words, they are not directly utilize the original data mining technique. They utilize some other technique to do the thing they like. Okay, so we will demonstrate one thing to you. Okay, but even though we utilize NLP the technique, and in the traditional NLP objective is try to understand what is the statement, and we'll be able to answer them. But text mining is more like trend. Okay, more like a trend. So we don't really need the answer. We just want to know the trend. So we can accept a lot of the noise as long as your data are big enough. But I have to say, right now, the boundary between them are become very, very blurred right now with the large language model. It's very, very blurred. Okay, so we want to show you one very typical example in the text mining called topic mining. Okay, topic mining is more like something, for example, do you guys know that we're talking about recommendation before, right? But if you go to the Facebook, you will find out sometimes the Facebook will not find, sometimes, all the time. Facebook will show you so many advertisements and getting more advertisement than before. How they know those advertisements actually come from you might interest, because they actually try to see what are the text you write or the text you read, and then find a similar advertisement similar to it. So one way they can do that is go through the classifier and then to send the NLP to working on with it. But from the text mining point of it, they can do a topic mining approach as well. Then you might say, Professor, I really don't understand what's the difference between them. Topic mining, actually, you can imagine, I want to, because the time is not that like that, I want to know there's so many documents, okay? I want to know which topic these documents belong to. Okay, so what are those topics? The interesting part is what are those topics? If you consider them as classification problem, then it becomes supervised learning. You define what is called political class, what is called weather, what is called sports, what is travel, and then you show an example and identify, right now I have that document, this document is more political. But then what happens if some of the topic, some of the class are not predefined? Especially if I realize, let me try to do this one. Topic mining are particularly useful for something like if you don't know, you're having some article, they are quite similar already. And then you don't really know how else then you can find the hidden topic behind them. You want to know that, then you can utilize topic mining right here. Okay, so then they can utilize the term as topic. So let me try to go through them very quick right now. Okay, and then here today we want to go through, by the way, if I actually in my class, some of the slides, I will go through them very quickly. Okay, the reason I go through them quickly sometimes also because I'm short of time. And second, I go through them quickly for example, that is those things definitely will not show in our final exam. I go through them very quickly. So I will stay in the places I think they are quite important for you to understand them. But why I still having those slides if I do not having them in the final exam? Because you might need them later on when you try to process your data. So I leave them some trust as a keyword for you to searching for them. Okay, so for example, topic mining are still some kind of research topic. Later on, if you want to working on topic mining, this kind of research, you can go to refer to all the definition that we're talking about. So sometimes you'll find out the topic, I can choose. One slide, I can talk for 1 hour. One slide, I can also talking for 5 seconds. Depends on if I'm going to having that in my exam or not. And this topic mining right here, we want to introduce certain thing, probabilistic topic model approaches. Okay, So what they did is they think the topic should consist a lot of words, and all the words have their corresponding distribution. So for example, if they're sports related, I might having some weight for sport for 0.2. And then I actually were having something like if the sport related is Olympic game, so I have the game, this keyword inside. So I might have key game right here, or I actually have basketball, or I actually have NBA, and then they utilize these approaches to automatically learn what type of the word distribution within this topic. So far so good? So I will stay in one thing. And then the possible approaches for this probability topic modeling have two approaches. Last year, I only talking about bag of word approach. Last year, okay? This year, you will find out I actually adding some slide in the graph-based approach. So I talking about something called text rank. It's more like a revised version of the page rank. So they're having a similar idea of this one. And also we want to show the graph actually is a very useful approaches if there's something if you want to actually find some difference as compared to utilize only large language model. In my lab, we have experienced some of the information, we convert them to graph. You actually can maintain some information probably are not being captured by the large language model. But the graph actually you can imagine in the end all the attention mechanism become a huge graph. But then to learn those things, you need a lot of data. Sometimes we don't have big data, we have a smaller data. So for smaller data, we can utilize certain graph and then do some propagate between the different way, the result will get better. So that is why this year, I also put some slide on the graph. I'm guessing I probably don't have time to go through them in detail. But I give all the keywords, so in the end, if you want to know something about that, you can check those papers. Each slide later on, each slide is one paper. So then that is why I say I have difficulty may go through all of them. But give that paper, and if you need that, you probably can go to utilize that keyword to searching for it. And today we want to talking about approaches. I want to spend more time. It's about bag of word approach. We already know what is bag of word. Inside is a very famous example in the topic mining called LDA model. LDA model is something called generative model. So if you heard about the term called generative model, it means that they actually want to mimic their output should be equivalent to your input. Okay, so if you see anything called generative model in the machine learning approaches, is they try to mimic, okay, their input by utilize some of the information. Okay, before I go on, let's try to give you the next class lottery, and answer is topic modeling. Remember that the class 1 are the QR code you just scan before. I hope that you already have that. Okay, you're done, right? So can I move on? For those people who love equation, here is your equation. I still hate to talking about equation. Okay. By the way, those people who love, if you need the QR code for in-class TA right here. Okay, so then in the machine learning, they're also having another LDA called linear discriminant analysis. So you actually will know LDA has many LDA. And this LDA method actually is published 20 years ago. We're still talking about that because it's quite interesting for you to know they can utilize pure conditional probability to calculate certain topic. Okay, and then they have 3 different equations and look very fancy. Okay, but if I give you the answer behind those equations, you will understand that it's not as difficult as you think. Let me also give you another trick. If you are a master student, you really want to make your paper to be published, okay, it's better to have a lot of equations in your paper because your reviewer like that. You see, our student also asking for the equation. And so sometimes you need to have ability to convert a very simple concept into complicated equation. As complicated as possible. That is official joke actually published in IEEE transaction before. In IEEE transaction, they even demonstrate in the paper, in one of the, I don't know what it's called, it actually demonstrates some joke. You say today if you see 1, if you only write 1 plus 1 equal to 2, come on, no one are going to accept that. Okay, so then you can do one thing is convert the 1 into sine something. And then right here, convert them to cosine something. And right now, you actually do some calculus things and try to sum up the thing, blah, 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 blah. And then after that, sine theta is not difficult enough. Convert the theta into some different way. And then after that, adding another thing right here. In the end, they will become completely not recognizable. And people probably will accept you. That is a joke, okay? But I'm not saying they do this one. This equation look difficult, but if I go through, then you'll find out it's not that difficult. So in that paper, they're actually having that illustration. If you actually major in mathematics, you probably just stay right here. You can finish. You don't need to listen to the rest of them. But we want to show something to you. Use that example. So this, the same figure. Okay, then the thing you need to know is they pay attention to few different concepts. One concept is how many words. Remember, I want to mimic my input. So first, you need to know how many words you need to generate. Second, you're having a certain thing called direct distribution. Actually that is alpha or beta, so here is alpha, here's a beta, so that is something that we can learn. That is some of the distribution we can learn. What does that mean? You can imagine I can learn some distribution if I see some topic, okay, and based on that distribution, actually I will be able to know which word I'm going to pick. Take that example. If the topic is sports, assume previous one, you see this example? You can see here's a sport topic, okay? This distribution actually try to show something to me. I actually will have 20% of them actually will give you the output of the sports. And 1% give you game, and 0.5% give you basketball, something like that. So that is a distribution they're talking about. And then afterward, after I know that distribution, okay, I will pick the word based on the distribution. Understand? So I having some distribution. You can imagine the distribution is my knowledge, and the knowledge knowing that how the word associate to some of the topic. So if I repeat them right here, I will be able to generate. So this is assumption they have. If I do this one, I will be able to mimic the output that is almost similar to your input. So you can imagine, like right here, let me see. And I remember a long time ago when I talking about this one, I had student come from France, okay, and they tell me that they having their college entrance exam is they need to write a long essay about some philosophy question. Anyone know? And then during their high school time, they really try. 他们会做一个哲学考试，就是里头会有一些哲学的问题，然后他们就在上面回答说啊，如果拿破仑怎样怎样的话，我就怎样怎样。So they actually have some question. For example, like Napoleon, actually, if they did not die, something like that, and what happened, and they need to reason, say, oh, based on this one, or like when a human being actually need to forbid the tobacco actually being imported into certain things, some information like this one. And so they need to actually try to reason based on that, how they actually thinking this one should be working on. And my student tell me that during their training, they really know what type of the topic they actually been seeing, and then what kind of keyword they need to pick up to make sure the score are high enough. So that is an assumption you can thinking about. So let me try to give you an example. Assume today I have 5 words in my document. I actually will decide I want to have in the topic 1 is called food. Topic 2 is about cute animal. Then I can base on my distribution and directly picking the word, and then in the end I will having Brad's adorable dog eating banana. Okay, so by the way, again, try to remember one thing. LDA is a bag of word approach. When you actually see this one, bag of word approach, you need to know what it means. It means the order doesn't matter. Okay, so the order doesn't matter. I don't care about order. I just want the output get the exactly same word as my input. Okay, so that is why you call bag of word approach. Okay, so then how they try to, so the important thing during the learning is they need to learn this distribution, because we don't have the distribution, so we need to learn. So they do the learn, it's called keep sampling. It's one of the approaches to the sampling. Please don't ask me how this sampling is different from another sampling. You need to go to the statistic and to take another courses and actually give you so many different sampling approaches. Just assume this is called keep sampling. Okay, by the way, I'm not going to ask you that keep sampling in my final exam. But we try to show you the example. Assume I have 3 different documents. Assume this is very short corpus, and why? Because we will be able to demonstrate that in our slide. And then assume we say how many topics we will need to have. We say 2. Okay, so right now you just knowing that my model need to learn 2 topics from my corpus, 3 different documents. And then afterward, what they did, you will find out a lot of time from the machine learning or data mining process. If I don't know the answer, I will guessing them from random. And so because of it, if you took another course called randomized algorithm, I took this one before in my PhD. I hate that. Okay, but that is a very important topic. Why is it a very important topic? Because they will tell you that if that information is they do having the signal, they just try to compare with the random situation. If they are a lot higher as compared to random situation, which means something really there. So in order for that, so you will find out like our neural network, we're starting from random. Attention mechanism, we can starting from random. Why? Because if something really there, after a big corpus to be trained, that information actually you will actually do this adjustable parameter and make sure everything in the end will be right. Okay, so then right now after that we randomly, so right now first things for LDA to know is they delete the word they consider stop word. We also mentioned stop word last time, right? Just like the thing like I am of the thing that the one we don't really like, they delete the stop word, and afterward they will have in certain word they are not stop word, and then we randomly assign a word to different topic. So currently, I try to randomly assign them, and then you will see I assign them to 2 different colors. Fish, eat, vegetable, and then you will find out some of them belong to red, some of them belong to purple. That is randomly assigned. They start everything randomly, and then afterward, we check them one by one iteratively. What does that mean? I want to check, does this random assigned keyword are really right or not right? So, how to do that? I actually have 3 different conditional probability for me to check. The first one are conditional probability by given the document D. What are the chances for having topic T? So far so good for that one. So you can see, for example, this is document 1. In the document 1, we have 3 words. Okay, and then how many of them belong to red? And the 2 words belong to red. Okay, so then there are 0.67. So this 1, 2, 3, 4 belong to the document. I just utilize it very illustrative way. So you can see right now the purple, how many of them belong to purple? 33%. So far so good. So that is the first things about in the document and what are chances for having the topic. The next one, what are the probability? The probability is if that is about that topic, and then what are the chances to be likely to having that word? So how we try to calculate them? Again, go back right here. Okay, so right now, if I actually say that is red, okay, how many keywords in the red? Eat, vegetable, fish, pet, kitten. Okay, 1, 2, 3, 4, 5, 6. 6 words. And out of 6 words, and then I only show vegetable once. So then you got 0.17 is because it's 6, 1 divided by 6. Okay, so illustrate everything like that. So you can also go to the purple and do that information. So far so good, so that is the red one. I don't need to consider to go through them. And the next one is what I want to do is today, if I say, I'm not so sure, does this fish really red or not? So I randomly pick some word, like fish. Let me try to examine, is that really belong to red or that belong to purple? So when I pick them, and then I probably need to recalculate something, because the fish, I try to check the chances that supposedly it will belong to what did I do? Okay. Sorry. 为什么就跳出去了呢？ Okay, do the purple. So then I do the calculation to see that. So the thing we try to did is we do all the calculation and then multiply this one with another equation. Multiply these two. So basically they just multiply these two and see which one is higher. Right? So then right now you actually see that the belong to purple that is higher. Then afterward I'm changing this fish from original red to become purple. So far so good? So that is what they did. It's just like they actually try to go through every word and go for all the conditional probability because they believe either fish in the end supposedly should be related to that dog or related to some other things. Then let me try to fix between them. Okay, if they have the tendency to be good together in topic, they would likely to be changed together. That is original hypothesis right there. So then they actually go through this equation. The thing goes through that difficult is we already utilized that example to illustrate them. So go to the conditional probability and sum up to find out which one having the likely higher possibility, and then they become the answer for it. And but after they go through, go through all the words of many times, and then they were going to find, so then we know. So after they go through them, they will be able to say, after this LDA, I can tell you the sentence 1 having 14% of the topic 1, 85% of topic 2. And sentence 2 have the 85% of topic 1 and the 14% of topic 2 and this one. And then what is topic 1 and topic 2? Just like this. Okay, by the way, it's a very short sentence. You can imagine a hypothesis if the data actually belong together, and in the end you will find out they belong together to the topic. Those keywords will be crowd together, pick up together. Okay, and then there's also some other reminder. I remember before I went to give the talk in the industry, and the industry people tell me that, Professor, but we did that in our data set, but none of them work. The LDA, actually, if you check the original paper, they tell you they try to train on 10 or 20,000 of the document, and for like 200 topic. In the end, the topic are quite nice based on original paper. But many people actually say they did not work. Then that actually asks them, what are you trying? You try English data or Mandarin data? They say, we try Mandarin data. Because they say in English, in French, and everything work. How come when I try Mandarin data, it did not work? And I say, here, because Mandarin data did not structure like this way. Do you know? The Mandarin data did not structure like this way. 在中文写作文不是这样写的，你不会从头到尾都写一样的事情，这样你会觉得很无聊。Okay, so you actually go to see all the magazine paper. The magazine paper, if they're going to describe one person, they will not directly describe that person. They probably describe the building and then go to the company of the building he tried to construct it, and go to how he looks, and go to the certain example like that. And in the end, they probably were having something to conclude it. In Mandarin, we have a lot. When we write the essay, we actually talking about build up. That is why I find out when I try to advise students to write research, I will find out the Mandarin speaker, the research paper are so difficult to correct, because that is how the Mandarin speaker actually try to write. We usually actually just circling around. This is a key concept. Go to right here. Okay, but English, if you do the TOEIC exam or something like a GRE exam, you will find out English like this way. The first sentence should be the more important than that. And first sentence supposedly should be connect to the last sentence like this one. All the things they have the inference. So if you're working with the Mandarin data, you will find out it's a lot more difficult as compared to the English data. That makes the research interesting. But when you try to write your master's thesis, try to pay attention to. I see a lot of people really like this one. They're talking about same thing over and over in the paragraph, still talking about same thing. Okay, so then we have less than 10 minutes. Supposedly I want to talking about the graph. In the remaining part, I don't have time. So, but then let me try to show how they did this one to you in a very quick way, very quick way. Okay, so for example, what they did is first, they will try to make every word just like a note. And then after word, they actually utilize the age, how they next to each other to construct the age. So for example, I love actually is connect to each other, so I construct an age. I can actually construct the age in the next word, or that the word actually in between word, so I will have in the age like that. So you can utilize this way to construct graph. You can imagine that is a model before transformer come along. Okay, that is a model also try to talking about long dependency. And this because the text rank actually is quite a long time ago, 2024. That is time before we have the transformer model. The reason we still want to talking about that, because you can see about how they do the transform. We don't do the same transform anymore, but you can have a lot of data. So for example, timestamp. and how the behavior looks like. You can all convert them to the graph. So you can utilize, it doesn't need to be exactly the same, but they can be converted to the graph. Like how those things actually next to each other with a different time. And when you convert that graph guarantee the transformer do not know that, because you are the one to know how to construct it. And afterward, they can also construct with a different way to know in the end, just know they have a graph. In that graph, then we can assign the weight. Try to fine tune the weight. So then right here is utilize the way to fine tune. Again, you don't know how to fine tune, then if you learn the page rank, then you will knowing maybe they're having some damping factor. What does it mean? So for example, if this is important word, someone connect to it, and then they actually will share the weight. So if you connect to the weight, actually node actually is more important, the weight actually will be more important. But if you actually, for example, this is the yellow one, but then right now you actually having the green one right here. Okay, what does that mean? Which means they are the second hop. Okay, they are not directly belong to this yellow one, they are hopping. By doing the hopping, you damping, you actually decay the weight. Just like if I have, so for example, my TA, they are my student, okay? So how much I know them? Like 90%, okay? But my TA actually have their friend, okay? If their friend need to find me, they need to go through the TA and then find me. So the chances to likely to get me is lower than my student directly find me. That is a same strategy. Okay, by doing that, so you can have different kind of equation to working with it. You don't necessarily to having that one, but this is a very simple way. And then afterward, you can do this graph. This graph, the advantage is they can give you some structure and syntax information, and it can show you some mutual information. Afterward, you can see I finished that in like 3 minutes. Ha ha ha. Okay, if you don't understand, it's fine. Afterward, there are so many graphs, like this way, it's called graph convolution. GCN graph convolution. By the way, if you don't know them, after that, fine. The only thing I want you to know today is they actually have different way to convert your data to graph. If you convert your data to graph, you can maintain some mutual information between the node, if they are necessary. GCN is utilized the convolution the neural network one, but then consider that in the graph, and then try to do you can actually see here some weight right here, and how I try to aggregate this different way. So right now, I'm not intend to do this one. You can see actually they can do a lot of propagate. Okay, so many propagate, okay. And then many propagate, which means the equation in the end will look very difficult, but then that is something. Okay, they even put the attention neural network in the graph. Okay, so that is possible. Okay, so but then don't worry, I'm not going to do this one to you. Shoot, I finished them in 3 minutes. Okay. So in other words, don't worry, Professor, I don't know what's GCN, I don't know this game. I show those things to you to know that it's possible to convert the information to graph. And I'm going to show some example later how the graph can be reused and in some research. Okay, class lottery again, that is about topic modeling. I probably will like a little bit late, like 5 minutes late for today's session. Okay, so then we want to give you some text mining example. That is from one of my students, Ricky. He's an amazing student, you know. He usually did not perform well in final exam. And so if I actually pay attention to his course grade, you will consider he's not a good student because he only probably got like a B plus or A minus or something like that. But he's a person do very well in research. So, and then don't thinking about you can only receive high grade and to make everything successful. The reason he actually have a lot of ideal. The people who cannot focus usually have a lot of idea and he can implement them. After he implemented, he finished his master thesis, and around that time, we don't have a ready version to submit that to the top tier conference. And then he graduated and come back to me and said, Professor, I really want to finish my paper. And then after that, he spent another around like 6 months to make all the thing material ready and submit that to topic conference and get a paper being accepted. So please don't judge yourself based on the grade you receive. Okay, so then around that time, we want to do certain thing called timeline summarization. What it means, 懒人包. Okay, you know 懒人包 is mean like sometimes if a very, very complicated question, and then I have difficulty to understand what is the beginning, what is the end. And around that time, we want to do timeline summarization. The interesting part is, he is not a student thinking about want to do this one. Actually, there are another technical management student, and they try very wild for their spatial topic. And around that time, they just asked me, Professor, we actually thinking 懒人包 is quite interesting, this timeline summarization. Would that be doable? And I thinking about that, I said, yeah, that could be doable. And then once they did one, they did not do it very well. And this master student found out it's quite interesting, so then he decided to working on it. So what we are not intent to show you all the information thing right there. So we want to show you his figure. Okay. The reason we want to show that to you is in the end, I want to show the timeline summarization. So you will know they're having a time. You know they have a lot of article, and then we select the article, and how do we know the article in the end can be generated, this one. And then right here, we utilize graph. See, we do the graph. So that is why we say that is an example about the graph. And then right here, you see the ChatGPT. So which means we also utilize large language model. Okay, and then right here, what they did is the student actually proposed certain thing called protagonist detection, mean main leading actors detection. If today I actually having someone called Donald Trump, then Donald Trump will be my protagonist. And the graph right here is try to measure how the Donald Trump, this keyword, associate with other key concept through the time. So you see there's a different time model. Okay, and then we utilize the embedding. So here we utilize the embedding, and those embedding, we actually try to segment them based on the different time, and we construct another graph. In that graph, we have different kind of graph right here, and then we try to, you can imagine every node is some kind of keyword. And what are the keyword? The word inside, we utilize the embedding, okay, we learn. And then with the information, we can somehow fine tune my embedding right there with the graph. By the way, in the end, you still probably don't understand that. But one thing I want to that you know is we utilize the graph. Okay, inside the graph, we propagate the importance of the character inside the graph. And then for the graph right here, all the nodes, we don't starting from scratch. We're starting from large language models embedding. And afterward, we also introduce the time frame right here. And then done after that, so I actually don't, you can actually see the example, there are so many embedding, we come from different information, and then why is that important around that time? The student actually showed this one, say, this is a character, but the character name this one have many, many people. And then by actually knowing some embedding, you will find some of the embedding, they will usually correlated, some of the embedding they did not, so then you can remove them. Okay, and then we can also try to talking about, we actually also find out in the news, they have a lot of attention seeker. Okay, so if something come out, they usually want to say something to attract the popularity. So in our places, we utilize this protagonist to actually remove those one who are attention seeker. Okay, so in the end, okay, there are so many different ways to do the scoring and then different graphs. So we just try to show you that we have the different graph. And in the end, actually you can see that is his work. We compare with a different method, and then we show that, for example, here are the different methods. The score is this much, but we can improve our score due to this high. So then because of that, with so many different comparison, and then we actually got the paper being selected by utilize the graph. That is why we want to show something to you. So the large language model doesn't need to be only large language model. You can combine with different other mechanisms to working with it. And then that is the example you try, but this is in Mandarin, okay? So we don't want to show that to you. Okay, so then few minutes. So then let's try to summary. Today we're talking about Pegasus, and the important for us to knowing that is sometimes if you fine tune things and max the information differently, you will get the result. Okay, and then we also try to show you the source of large language model ability come from huge parameter size. So then you heard NLP more slow. Every year model size increased by 10 times. And then you also like to have a hallucination problem is because human being reward guessing. And then if you could, please utilize a better prompting. Okay, in the text mining one, we actually talking about, we want to say the text mining important is try to get the trend. And because unlikely we don't have much time, we show you the LDA. LDA is a more generative model. And we also show you the information can be converted as a graph. And combine all of them together, you can find something interesting. Okay, so that will be it for today's session. 3 minutes later. So that is our 1 minute reflection. And afterward, our TA will come here to do the lottery. So that is the first one from the
1 minute reflection.
1 minute reflection from which
September 29 and October.
September 29 and October 13. Okay. So you put that together?
Yeah.
Why you put that together?
Because last session you asked Alaya for this session to 1 minute reflection together. Last session you said to Alaya that we need to group the 1 minute reflection of September 29 and October 30.
One second. I think we already do September 29 before, right?
I think 22.
Okay. So then which means 1 minute reflection, usually we can only do 3, so we will have 6 people for that. Okay.
Okay.
No, because we actually having some courses missing, so. Ready? Okay, go. So did you click?
Yes.
Everything now.
Yeah.
Oh, okay, so then the first one come out 114062599. Is the person here? So next one. One 111034043. Okay, next one. G1323000105. 114065527. One 111062209. One more. This is for 1 minute reflection for September 22 and September 29.
people together. Okay, so that's for 1 minute reflection. Next one is for our online class lottery. This is online?
This is in class. Okay. Online first.
Yeah, online first.
Okay.
How many people online? 74. Okay. Okay, go. One one 2096029. Is that person here? No. How many people do you think? I already forget.
6 for online as well.
6 for online. Okay. S11135535 from different school, I guess. Go. Remove. One 113086852. One 1406549. 2 more. One 1406265. A14546203. Okay, online and in class. How many people were in class?
I think
4. You got good chance today, right? You have it best?
around 15. Okay.
One 113078512. The person here? Yeah. 第一次吗？第一次。Good. 机会很大，人人都有机会。111071038. Who is that person? 应该不是第一次吧？第3次，运气很好。The third time. You guys also do maybe right?
We have it like trees.
One 112070034. Who's that person? 你也应该不是第一次吧？是第一次，不是吗？对 ，OK。111034043. Who's that person? 你也不是第一次吧？对 ，OK。你也是第一次哦。哦，好，不错，终于轮到你了。Two more. 113162862. Who's that? Here. Maybe just work out. Move.
Yes, guys.
And the final draw goes to.
Oh! 114-003805. Who's that person? 你是第一次吗？哦，你是第一次。Okay, fine. We have many. It's done. 1, 2, 3, 4, 5, 6. Done. Thank you. See you guys next week.